Hey guys, it's Miss Miriam. This is the first time that I have ever recorded a lesson like this, so there are probably going to be hiccups, so just bear with me. I know you guys are missing me a lot, but I will be back soon, and we are gracious that Miss Stacy and Zach have stepped in. So if you have any questions while I'm explaining this, obviously you're not going to be able to ask me. But you can ask one of them, whoever's in the room with you, and hopefully they'll be able to work you through this. Now, you have notes in front of you, and if you notice, it's all story problems. And everyone's favorite thing to do, right? And I know that you are groaning right now, but the fact is you're in Algebra 2, and so you have to step it up a notch, okay? So here we go. You have already hopefully worked through different kinds of logarithms and properties of logs yesterday or the day before, or maybe you were playing catch up today, but either way, when you see the log, it should not be brand new to you, okay? Okay, I will tell you from the beginning that this is going to be pretty rough because the pen that I'm using is really big and bulky, so my handwriting is going to be awful. But bear with me. All right, so we're going to talk about actually three formulas that deal with exponentials and logarithms when we're talking about story problems or application problems. The first one is going to be whether we are discussing exponential growth or decay. And if you think about it, if you buy a car brand new and you drive it off the lot, you know that it depreciates as soon as you drive it off the lot. So that would mean that the price is going down. Sometimes if you buy a house and you do work to it and you remodel it, the value of that house will appreciate, which means it's growing exponentially in the value. So based on the story problem, you're going to be able to figure out whether you have growth or decay. If you look at this formula, and I'm going to zoom in a little bit. If you look at this formula here, we are given this plus and minus thing. Do you guys see that? So plus or minus, we use plus if it's going to be appreciation and minus if it's going to be decay or depreciation over there. All right? So the first thing that we're going to do is we're going to read the story problem and then we're going to label everything. And if you notice here, it is labeling, whoa, okay. We see over here that Vn is the new value, P is the initial value, and initial means the starting value, right? And R means the rate. Now, some of you are going to have trouble figuring out what the rate is because of percentages. So the best way that I like to tell you is take the rate and divide it by 100. So if you need to write that down, put rate and then divide by 100. Whatever percent they give you, divide that by 100 and you will get the correct decimal. And then N is going to be our time, so number of years or months or what have you. So this formula that they give you on the left is going to be really, really important while we're doing these types of problems. In your homework, it's not going to tell you which formula to use of the three, so it's really important to make sure that you are paying attention and trying to read the question as it is, okay? All right, so let me get ready and then we will start the problem. I'm trying to give myself enough space to write because, like I said, I got the fat pen today. All right. According to Indianapolis market trends, the average list price of a home in Indy is $162,000 and it is increasing 2.5% annually. All right, so the first thing that I like to do is identify everything that we've been given. We can write our formula down here. P to the 1. Now, is this going to be plus or minus? Well, if we look here, it says increasing, so this would be plus. So we're going to say plus r raised to the n power. Now that n is an exponent, remember? So Vn means the new value. Well, if we read part A, it says, if this trend continues, find the average list price of a home in Indianapolis in 5 years. So in 5 years, that's going to be our new value. So that's actually what we're trying to find is Vn. All right, so we're going to leave Vn alone because we don't know what that is and that's what we're solving for. So our P stands for initial value. Now, why did they use P instead of like I? Who knows? I didn't make the rules. I'm just teaching you how to do it, right? Okay, so if we look over here in the story poem, it says 162,000. Well, that's the starting price of the house. So I'm going to put 162,000 in here for my P. Parenthesis, that 1 is always there. No matter what, the 1 is always there. Plus our rate. And if we do our rate, again, would you guys agree that 2.5% is going to be my rate? If you don't know how to convert that to an actual decimal, because that's not really the decimal answer, you can take 2.5 in your calculator and divide it by 100. Or you can move the decimal place to the left 2 places, because 100 means 2 places. So if we do that, then we get 0.025 raised to the n power. All right, so now we have to, except we do know n, don't we? Shoot. Thanks, guys, for catching that. All right, so we know n, which is our time, right? And it says our time is 5 years. Okay, so t is going to be, or I'm sorry, n is going to be 5. So we'll put to the 5th power up here. All right, so now if you notice, the only missing variable that I have is this vn right here. So that's the only thing that I'm missing, which means I need to solve the right side of the problem. So if we think about order of operations, first of all, I'm going to put 162,000. And 1 plus 0.025 is 1.025 raised to the 5th power. Trying to let you catch up. I'm trying to imagine myself writing at the board and getting out of the way so you can write it down and yada yada. Okay, so order of operations says we should multiply here first, or we should take 1.025 to the 5th power. Which is it? Go ahead and answer out loud. I know I'm not there, but whoever's there with you, Zach, can tell you if you're right or not. Okay, order of operations says we have to do this first. Okay, so take your calculator and do 1.025 raised to the 5th power. I will pause for a minute while you grab your calculators, because I know some of you do not have them yet, so hustle. Alright, so if we get 1.025 raised to the 5th power, we get 1.1314. And we're going to multiply that times 162,000. Now, you don't have to write this down necessarily. You don't have to write down the 1.1314 because your calculator will store it. So while that's on the screen, the 1.1314, just hit times 162,000. So we're going to multiply these two things together. And you should be getting $183,288.13. That is going to be the new value of the house after 5 years. And it makes sense, right, that the value is increasing because it started at 162,000 up here. Can you guys see when I change my color? I wonder if you can. This is what our starting value was. Okay, and so we've increased, so it makes sense that we would increase however much, and we did. And so our new value of our house then is $183,288.13. Now, if you are off by like a decimal point, or I'm sorry, like if you got 14 on your calculator or something, it's not a big deal. I just want to make sure you have the overall process correct. Okay? Any questions? Okay, going on to part B then, it says, in how many years will the list price be at $190,000? Okay, so now this is asking me something different. It's saying in how many years, so it wants me to solve for years, which represents time, the value of n. All right, so we're always going to start by writing our formula down, and then we're going to fill in the missing pieces. So we're using the same formula that we just used above. We are still appreciating, right? The value of the house is still growing. So we're going to put a plus still. All right. It says this time, however, the new price is going to be $190,000. So this here becomes my VN. So I'm going to plug 190,000 in over here. Equals, my initial price of the house didn't change, right? It's still $162,000. The rate hasn't gone up. And we can take a shortcut, right? We know the rate is 1 plus 0.025. So let's just write 1.025. My decimal point is not showing up very well. There it is. Now this time they're saying in how many years? So this time they're asking me to solve for n. So I'm going to leave n there. Okay, so this is what our equation looks like. So if we are solving for n here, the first thing I need to get rid of is what? Think about your order of operations. We're working backwards. If I multiply these two together right here, that means I'm really discounting what this exponent's doing over here with the n. Okay, so I'm not going to do that. I'm actually going to divide each side by 162,000 because I need to get that off there. So it cancels here and cancels here. But again, whatever you do to one side, you have to do to the other side. Okay. Now here's a shortcut I want to show you. You can actually, when you have a problem like this over here, some big crazy number, do not put that into your calculator and give a decimal answer. We want this problem to be as exact as possible, so I don't want you to put it into your calculator and give me a decimal. We're going to leave it as a fraction. However, we can knock out these zeros. Okay, so then let's simplify. I'm left with 190 over 162 equals 1.025 raised to the n power. Now, what are we supposed to do? I know you're all just staring there in silence because I'm silent, aren't you? Okay, so let's think about this. Does this look vaguely familiar to something you have already done yesterday? Yes? B to the y equals x, where our b would be 1.025, our y exponent would be the n exponent, our x would be this fraction over here. Okay, so you guys have already learned this, but the problem is I need to put this into log form so that I can then use my calculator. Okay, so I'm going to erase this over here so I have some room to write. Will you remember what the problem was? All right, so if I turn this into log form, remember our log form is log base b x equals y. I know Zach taught you that yesterday. Okay, so I'm going to write log. Man, my handwriting is terrible. Sorry, guys. Of what's my base here? Remember, base is b, so log of base 1.025, and my screen is not doing a very good job, but that needs to be small. Right, that's like the little, it's called the subscript when it's little like that. Log base 1.025 of x. Okay, well my x is that big fraction, so I'm going to put in parentheses 190 over 162. And then my y value was n. And remember, n, the exponent over here, drops down to become the n over there. Okay, so now how are we supposed to do this? I hope you're shouting out answers. Any ideas? You learned a formula yesterday, because when we cannot put this into our calculator, and why can't we put this into our calculator? Because it's not base 10, right? It's base 1.025. And our calculator, remember, is programmed just to be log base 10. So I can't put this into my calculator. So I use my change of base formula. Do you guys remember that? Where you do, let me get a different color pen here. where we do log base 10 of b divided by log base 10 of a. Do you guys remember doing that yesterday, where this one is your b, this is your b, so it's going to go up to the b to the top of the fraction, and this is going to be your a, so it's going to go down. All right, so what this basically looks like, let me erase this over here. I'm running out of room. This thing's pretty cool, huh, guys? I know you're thinking that right now. All right, so this is going to be log base 10 of that entire fraction goes up there, and that looks really awkward and ugly. I know that, but it's how it's done. Over log 10 of 1.025. And now you're thinking, we are still on the same dang problem and it's been like 7 minutes. You're right, but this is the first time that you've seen this, and so that's why I'm going slow. Okay, once you get the hang of it, like usual, you'll be able to go faster. So when you put this into your calculator, you need to be very careful. In fact, I would put, this is how I would do it, so watch carefully, please. I would put this into my calculator. So log of 190 divided by 162. Put the fraction in parentheses like it's in there. And then equal it out. Push enter. And then divide by log 1.025. Okay, I'll give you a second to do that. If you get an answer that doesn't seem reasonable, then you need to check it again. Remember what we're solving for, right? We are solving for we're solving for time. So if you get like 2,000, obviously you've done something wrong. Or if you get like 0.13, you have done something wrong. You should be getting n equals 6.46 approximately. And that seems about right after almost 6.5 years. The value will be 190,000. Okay, I'm going to ask Zach to pause it right now so that if you did not get 6.46, you can work with a neighbor or with Zach and to figure out how to put it into your calculator. Okay, problem number 2. Zach bought a new car. Oh, did you, Zach? What kind of car did you buy? Sweet. At $21,500, this car depreciates at a rate of 1.25% per month. Okay, so we have some things here. First of all, the car was valued at $21,500. Now, this is not the new value, even though it's a new car, okay? Don't let that be confusing to you. When we say a new car that's valued at that means the starting price, right? So this is going to be our VN. The first thing to do when you're doing these, by the way, is to label everything in your story problem like we're doing here. It says the car depreciates, which means it's decreasing in value. So we should be subtracting that in that parenthesis, the 1 minus the rate. Okay, and then it tells you here your rate is 1.25%. Now again, if you don't remember what that is as a decimal, you can do 1.25 divided by 100, which turns out to be 0.0125. Okay, and then it gives us time per month, but we don't know how many months yet, so let's hold off. Oh, I just realized something. This is not our VN. Thank you guys for correcting that. This should be our P, our initial value. My bad. I cannot go back and erase my comments because it will take forever. So we'll just erase that and change that to be our P initial value. Checking to see if anyone caught that. Michael, thank you for paying attention. All right, if Zach's auto loan is for 4 years, how much will the car be worth when he makes his last payment? Okay, so now they're giving us the time, 4 years, okay? So that's going to represent our N. So again, the first thing we do, remember, is to write our formula down. We're going to use subtraction this time. How much will the car be worth when he makes his last payment? So what will the new value be when he makes his last payment? So we are solving for VN. Our initial value is 21,500. 500. This must have been his graduation present to himself. 1 minus 0.0125. Now, question, what is our n? Is it 4? If you put 4, you need to be really careful because it says per month. So how many months are in 4 years? Well, 12 months times 4, 48. So our n is actually 48. We have to be really careful about that, okay? All right, so now, since we're solving for Vn over here, all we have to do is simplify the right side of the problem. So order of operations says 21,500. What is 1 minus 0.0125? Please enter it carefully into your calculator. You should get 0.9875 raised to the 48th power. Now, according to order of operations, what should happen first? Should we raise it to the exponent or should we multiply by 21,000? You're right, we have to raise it to the exponent. So take 0.9875 raised to the 48th power. Remember, we use that little caret button. If you need help, please ask Zach or a classmate. And then you don't have to, it's going to give you a really long decimal. Please don't write that decimal all out. While you have that answer in your calculator, just hit times 21,500 and it should give you your answer. We should be getting $11,754.91. Now remember, his car is depreciating in value, right? So it's losing value. So that makes sense that his car is depreciating. So because we are in Algebra 2, we're going to write a sentence each time, and I did make you do it above because I wanted you just to make sure you understood the process of what we were doing. But because we are in Algebra 2, we're going to write a sentence. So we would say something to the effect of, Zach's car will be worth $11,754.91 after 4 years. Okay? This right here is what you're going to get full credit for. I need you to put it into a sentence because you're in Algebra 2, so you can write a description. Okay? Okay, part B says, in how many years will the car be valued at $7,000? Okay, so when it asks for how many years, we are solving for n, right? Whenever it's asking you for time, how many years, that's the big hint that you're going to have to use the change of base formula, okay? So if you're solving for n, which is the exponent, you're going to have to use change of base. So write small. I tried to give you enough room on these papers, but try to write small because we're going to have to do a lot of work like we did in problem number 1, part B. It's the same type of problem here. In how many years will the car be valued at 7,000? So now 7,000 becomes my Vn. I'm going to switch back to black here. Okay, so let's start again by writing our formula. You can never go wrong by writing your formula. 1 minus r raised to the n. Remember, we're subtracting because this car is depreciating in value. So now this time we know what Vn is, so we're going to put 7,000 in. The initial value that he bought the car has not changed. It's still 21,500. Again, we can take the shortcut because up in a problem letter A, we found out what 1 minus the rate was, and we get 0.9875 raised to the n. Alright, so if we look back at problem letter B in problem number 1, what was the next step? Remember, we are solving for n. So we have to move everything over to the left side. So the first thing we should move is the 21,500. We have to get rid of that. So we're going to divide by 21,500. Cancels out over here. Now, are you allowed to do a decimal? Remember, no. But we can take a shortcut. We can knock out two sets of zeros. They have to be the same number of zeros on the top as on the bottom that you cancel out. Okay, so let's simplify. I'm then left with 70 over 215 equals 0.9875 raised to the n power. And if we remember correctly, this is b to the y equals x. And we can change it into log form. That's our next step. Okay, so log base 0.9875. It's really hard to write small with this pen, so just remember my handwriting is terrible. And then our entire x, remember, is that whole big fraction equals n. Okay, so remember we can't evaluate this because our calculator is programmed to be log base 10, so we do change of base where, I don't know if you guys realize this is a shortcut, I kind of showed you before. Whatever is the base down here goes down on the denominator of the fraction, and because this big fraction right here in parentheses is up higher, it's going to go up to the top. So we should have log base 10 of 70 over 215 divided by log base 10 of 0.9875. Remember when you're plugging this into your calculator to do it very carefully. So I would take log base 10 of 70 divided by 215, put that whole thing in parentheses like it is there, and push your enter, push your equals. You don't have to write that decimal down, but push equals. And then you're going to divide that by log 0.9875. Okay, and the answer we should be getting is, I think it's 7.42. Is that correct? Let me pause real quick to check. Oh yeah, I forgot. Okay, actually when we do this, you haven't done anything wrong, but we get like 89.2. Is that right? So that's what you guys should be getting. Now, does it make sense that after 89 years, his car is going to be worth $7,000? No, it doesn't. That's ridiculous. Okay? That would be a heck of a car that after 89 years, it's still worth $7,000. So remember, though, if you look in part A, what was our unit of time? Wasn't it per month? So this 89.2 represents the number of months. So if we want the number of years, we need to divide by 12. So if I take that divided by 12, I get approximately 7.43. And remember, because we are in Algebra 2, we're going to write a sentence. So after, and you can say like approximately 7.5 years if you want to do that, as long as you have your work showing and you use the word approximately. 7.5 years, his car will be worth $7,000. Okay, so this would be your answer. Remember, you have to write it in a sentence to get full credit. Okay, problem number 3. So again, we're still doing the same process. According to the 2010 census, the fastest growing city in the U.S. is Austin, Texas. In 2011, Austin had a population of 790,390 people. Its population has been growing at a rate of 2.04% per year. Estimate the population in 2021. All right, so again, before we start to identify anything, let's just write our formula down. Are we growing or are we declining? Well, if we look here, it says it's been growing, so that means we need a plus for our rate. Okay, let's look for our initial value. What's our starting number? You guys would say here our population number is our P. That's our starting value. It tells me my rate is here. But remember, as a decimal, that's actually 0.0204. Oh no. Did all that just erase on yours? Sweet. Just write it again. Okay, and then it needs to know what our time is. All right, so let's fill in with what we know. We said this was P. So 790,390. 1 plus 0.0204 is going to give me 1.0204. Now, what's our in? Because they asked us to find what's the new value of population after in 2021. So what's our in? Not 2011. How many years have passed since 2011? Right, so if we look at 2011 and now the year is 2021, how many years have passed? Well, again, if you do some simple subtraction over here, 2021 minus 2011, we get 10. Although you should have been able to do that in your head, I hope. No one put that in their calculator. But I'm not there to see, so just pretend like no one did. Okay. Order of operations says if we look, well, first of all, what are we solving for? We're just solving for Vn over here. Right? So that means all I need to do really is evaluate the right side. So remember, order of operations says I need to do this first. So in your calculator, 1.0204 raised to the 10th power. Please be careful to make sure you put in the right decimals. And remember, you don't have to write that number down. Just now in your calculator, multiply times 790,390. I'll give you a second to make sure you do that. And you should be getting 967,266. Now it says 0.03, but can you have 0.03 of a person? The answer is no. So we're just going to leave it there. So that's our final answer, but actually it's not, because remember, we're in Algebra 2, so we have to write sentences. In 2021, the population should be, because remember we're predicting, 967,266. That's what you get full credit for. Okay? Now at this time, we're going to switch formulas. So I'm going to pause this video, and then now Zach can play the other video, and we will get started on problem 4 and 5. I know you can hardly wait.